So electromagnetic induction, mostly fine, although I do suspect a few more doubts will creep up since I've not completely solved the exercises, especially the advanced portions. But I'll deal with them when they do come up. Right now in Alan, they've already started AC.
Okay, right. So if I ask you what is flux linking through a solenoid, I presume solenoid will be known to you. Let's say there's a solenoid and we are to find what is flux linking through solenoid. But there is a condition with this solenoid, and that being either it is, which is not practically possible, of infinite length and significant radius. I repeat, either it is of infinite length and significant radius, or it is of significant length and infinitesimally small radius.
So
Okay,
both
it's an
conditions
analogy.
seem flawed, at least. I mean, how can it
Both
be
are
infinitely
flawed, but
long and have a
concept.
significant radius?
Yeah, they are flawed. There is no two way about it. But we are bringing it closer to what in practicality can exist. We cannot certainly have something which is of infinite length and significant radius. So analogy that we are to draw over here will be against a solenoid which is of insignificant radius and significant length. Instead of infinite length, we are taking significant length. And instead of finite radius, we are associating with it insignificantly small radius. Am I clear? It is an analogy drawn similar to what I did show you. This is to me visible, but if I bring very close, it will be apparent infinitely spread to me, correct? As well, I'll not be able to see the edges. So what is the analogy drawn over here? Either the sheet is infinitely spread or you are very close to it, correct? It's all the way the same. Either you say it's of infinite length and finite radius, or we say it is of insignificantly small radius and finite length. Okay?
Yes.
Now, why is this analogy being drawn? We are drawing this analogy just to facilitate getting B field, magnetic field in the core of a solenoid. We can do this analogy, and this analogy will hold water only for calculation of magnetic field. It is being used against Ampere's circuital law, which otherwise will not be feasible if I am taking anything as a departure from what we have already stated, and that being either infinitely long significant radius or finite length insignificantly small radius. Got it here?
Yes.
And what I'm using over here, B dot dl is equal to mu naught I. Okay, I'm using over here B dot dl is equal to mu naught I. What I've taken over here is a square of certain, or a rectangle of certain length. We'll take a rectangle of certain length. I'll show you over here. We'll take a rectangle of certain length. Just a minute.
So are you going over the derivation of the magnetic field inside such a
No, no,
solenoid?
no, no, I'm not going for derivation. This is the prelude for where we'll be going, and that is in reactance today. I'm no more going for what we are through. Okay? Is it okay?
Yes.
What I'm to show you is very simple. There's nothing much to be shown over here. This is the case with me. This is the solenoid to me. I take a small portion over here and find B dot dl for this portion. B dot dl for this will exist. For this part, B dot dl will be 0. Please check the point. This part, B dot dl will be 0 because B and dl will make what angle?
90.
B and dl will make 90 degree. And this part now. This part will be 0. Why? Because there is no B present. And when can we buttress the point of B being in absentia? We can buttress the point of B being in absentia if and only if we are adhering to the precedence that we have set and what premise we began with, you are aware of it, correct? If we're sticking to that premise, then we can profess the idea of B being 0 anywhere out of the solenoid. There'll be no B present outside. So for this portion, B dot dl will be 0 owing to B being 0. And for this portion, B dot dl will be 0. Why? Because angle between B and dl is 90 degrees. Clear? Then again, this portion B dot dl 0, there is no B present. This portion B dot dl 0, for same reason, no B present. This portion B dot dl 0, why? Because B and dl are making an angle 90 degree. So we eventuated with only this portion. This is the portion to which it will boil down, and what we can write for it? Simple. B and the length dl is equal to what to us? Mu naught into n being the number of turns per unit length. Okay, I'm assuming n to be the number of turns per unit length. So this length, how many turns it will contain? N is number of turn per unit length, and what length we are associating with?
L.
N. I is the current, and
Yes.
that gets us B is equal to what to us? Mu naught N I. This is known to us for infinitely long. We are aware of B is mu naught N I. Well, I'm not over here to get D from you, but flux. So could you please tell me what will be flux linking to the area, cross-sectional area?
So it'll,
What
if you're
flux-
if you're taking per unit length,
Yeah.
it'll be
So cross-section area. This is the cross-section area. R is the radius. R is the radius. I want to link it through the cross-sectional area. So I'll get it as mu naught Ni into pi r square.
yes.
Mu naught Ni into pi r square. This is what we'll write henceforth as pi is equal to L into I. Okay, where what is L? You can very well gauge from here, right?
Yes, sir.
What is L? L is mu naught N pi r square.
So it's basically flux per unit current. Okay.
Correct. Let's change. Let's change flux. Now d phi by dt is what we see. What will be d phi by dt? D phi by dt will be E is equal to minus of d phi by dt though. But I am writing over here as per Faraday law of electromagnetic induction, E is equal to d phi by dt. And what is this to us? L di by dt. Okay? Is
Yes.
equal to L di by dt. Please do check. Visible?
Yes.
Okay. So it's L di by dt is what we are getting. This is EMF generated. Now we need to learn what it is all about. What is over here L to stand for? What is it called? Yes, please tell me.
Inductance.
Inductance. Okay. And how is inductance? Which kind of inductance, by the way, it is? Self. There are two
So,
kind of inductance.
self,
One
in
is
this
self,
case.
yes. This is self-inductance. Okay. And self-inductance is to be related with reactance. And then reactance will be related with resistance. So what I do over here is I show you a solenoid and ask you about what will be nature of this solenoid I. This EMF, what will this EMF do if I'm increasing current? Let us say I is equal to I naught sine of the angle omega t. I have taken a current which is changing with time. It's alternating current, it's AC. How do you generate AC? How we generate AC?
So the traditional
Yeah,
method is the only one I'm aware of, like turn a coil in a constant magnetic field.
Correct. So we will turn a coil. Let's say I have taken this as the plate and I keep it in the confinement of magnet. Flux linking with it will change owing to change in angle. Area is not changing, mind you. If any point in time you find flux, let us say we get B dot A. B is constant, area is constant, cos of the angle omega t you can write depending on from where you're taking the measurement, what is the benchmark. And then you will get to see that if you change, you will get E is equal to how much? Minus of d pi by dt if the direction is also taken into account. So B A W sine of the angle omega t is what we will get E as. EMF generated, if R is the total resistance of the coil, then E by R will get you how much? B A omega by R sine of the angle omega t, and B A omega can be written as I max. I max sine of the angle omega t. Please check there. So
Yes,
this
sir.
is I to. This is how I is varying.
So I have one doubt that's been like persisting for quite a while. What is exactly the significance of the sign we attach with the EMF?
The opposition. It will be in opposition.
Okay, I
And that
get
is what
that. I get that it's opposing it, but how do you condense? I mean, how do you relate the fact that it's opposing the change in flux
exactly, that is
to
the
a
point which I'm raising over here. Look, over here, what is happening? I is, let us say I'm starting from t equal to 0. If I start from t equal to 0, then I is increasing, correct? So flux linking through this solenoid is increasing.
Yes.
What will the solenoid act? The solenoid will act a battery with this polarity. The solenoid will act a battery with this polarity. The moment you have taken increment into account, now you will not write minus of L di by dt. You will write, if this point is A and this point B, you have taken increment into account, correct?
Yes, sir.
So what will you write? VAB in this case, simple L di by dt. There will be no negative sign. On the other hand, if I am to take it beyond pi by 2, let's say, then current start decreasing, correct? So what will the solenoid do now? It will try to increase it. How can it increase it? By reinforcing it in this direction.
Yes.
It will reinforce current in this direction. Then what will be VAB to me? Then VAB will be minus of L di by dt, correct?
So,
It's VA minus B.
Okay, so initially the current is increasing, so
Yes.
the inductor wants to oppose that.
Correct.
So the potential
Potential being?
potential increases
Opposition.
across potential increases
Yes.
from A to B.
Yes, yes.
All right. Okay, fine. I get it.
So the correct equation now I need to bring to you. Why do we have these supersons of doubts? Because the correct equation are not known to us. The correct equation in this case is VL di by dt, the mod of it. It should be correctly mentioned. VAB will be VAB equal to mod of L di by dt. And in accordance, you have to change. The current increasing or the current is decreasing. If it's increasing, it will take the shape L di by dt, decreasing minus of L di by dt. And here?
Sir, but if you say VAB is L di by dt, that means A is always at a higher potential than B, right?
That will happen in the case when di by dt is positive, right?
Yes, sir. So, but then if you define VAB as equal to the modulus of something, that means the VAB is always a positive value.
Yeah, VAB will always be over here a value which is positive. I'm associating it with the current here. I have to make it positive accordingly. VAB, when I'm writing VAB, I have to give it a sign. It will be when you remove VAB, the mod when you remove, you write plus minus, right?
Mm-hmm.
When I remove mod, I will write VAB is equal to plus minus.
Yes, sir. But whenever you do write a minus, that will be cancelling out a negative inherent in the inside expression. So ultimately, you will always get a positive value.
No. It is always believed that when you're writing VAB, you are writing with the context when we have assumed VAB to be positive and it is vis-a-vis current increment. It cannot be with current decrement case. And this you will see more being reinforced when we are charging or discharging an inductor. Because if we are not taking in consonance with what being professed over here, you will yourself see how we will be landing ourselves into. So that will be taken in this class per se. You will get to know what exactly is the reason for incorporating mod to it and how it is immuning us from any erroneous calculation later. So what I do, but before going into that, we need to, as I told you, establish a relation between a resistance and reactance to know what reactance actually is. What is reactance over here? Let me ask you, what is VAB? If I write VAB for R, a resistance, pure resistor. If I write for a pure resistor, this is A, this is B, then what my equation will read, VAB is equal to IR, correct?
Yes, sir.
We now take an inductor and ask you for increment of current. I'm keeping current increment. Current increment nature intact, that is not being changed. Current is increasing. So whatever I write VAB now, this is A, this is B. Whatever I write VAB now, you are known to it. VAB will be what to us? Will be L di by dt. Just now we got.
L di by
right? VAB will be L. The current is increasing. So VAB will be equal to L di by dt, correct?
Yes.
Now L is it and di by dt. What I we got from here? This is the I which I'm following. I is equal to I max sine of the angle omega t, correct? Now differentiate this. Di by dt. What do we get?
Omega
We
I
get
max
I max
cos omega t.
omega cos of the angle omega t, right?
Yes.
Okay. Now check this factor, please. Leave I max and cos omega t for a time being. I max and time factor. I max is the maximum current, which is actually current anyway. And cos omega t is indicative of it changing with time. So if I bar myself of I max cos omega t, just trying to ignore the elephant in the room, what do I get is I max cos omega. This is current function. I max cos omega t is current function. Similar to what was I over here. Here it is I max omega t is a current function. Similar to what was I over here. But in case of resistor, you had R. What do we get over here is omega L. What do we get over here? Omega L, correct?
So basically the coefficient of current.
Yes.
Okay.
What is being current accompanied with? Not coefficient, what is being current accompanied with? So the term which is current being accompanied with over here is what is called reactance. This will call reactance. The term which it is associated, current component is associated with the term, it is called reactance. I'm marking XL for it. Why? Because I've used inductor. So precising to what we have used, the component electric that we have used, it is called inductive reactance. It is called inductive reactance. Got it here? Omega L. I take now capacitor here. Next, capacitor you are aware of. Tell me what will be VAB. VAB. Can we say VAB will be equal to Q by C?
Yes.
VAB will be equal to Q by C. Q will be how much? I dt integration by C.
Yes.
Okay. Integration of sine omega. I max sine omega t, how much will it be? I max by omega and C as it is, right?
Yes.
Integration of sine omega t.
Cos omega t.
Cos omega t. The
Negative.
negative sign, correct?
Yes.
The negative. Do check here. Now VAB. VAB I write yet again. I max by omega c. And I want to take this inside. Now there are two ways of taking it inside. I want to take the minus sign inside. We can write it as sine of the angle 90 plus omega t. Right?
Yes.
It can be done. Sine, if I want to keep it in sine, then sine of the angle 90 plus omega t. Allowed?
Yes.
And what else? Cos is to be changed. I don't want it to be cos. I want it to be in sine. So two ways of using it. Sine of the angle 90 minus omega t I use. So I'm using both, by the way, for you. Sine of the angle, I do it this way. 90 minus omega t I use. Okay, done. And the minus sign is out.
Yes.
Sine 90 minus omega t. It's cos omega t minus 310, correct? Now I max by omega c, I take my sign, negative sign inside. What I am getting then is omega t minus of pi by 2. Do check and endorse it. Is it fine?
Yes.
Okay. What is this to use? Correct? What otherwise we can use? What otherwise can we use? Can we use another equation for this minus to be incorporated? One was to convert it and minus being taken inside. Any other way so that the minus is in?
So when you say any other way, why can't you? I mean,
Trigonometric.
what did you say?
Trigonometrical.
Okay. So if you want to remain in cos, right? So you could just write cos omega t plus pi. That would incorporate the negative sign.
Okay. That is another way out. We'll be looking into both the ways. I begin with the one which is there on the paper first, and I'll ask you, do you know anything about, or can you recollect, do you have any reminiscence as of now on phase, which you have studied in simple harmonic motion?
Yes.
Okay. So current is I max sine of the angle omega t, and I have brought in the sine term VAB. Which one is leading and by what angle?
Omega t is leading by 90 degrees.
So which one is leading? Current is leading or voltage is leading?
Current,
Current leads voltage by what angle?
90.
In case of
Capacitor.
now we go to the other case, which is this. Okay,
Yes.
we can write accordingly. This as XL I max. Now I'm writing the equation for you. First is sine of the angle 90 minus omega t, correct?
Yes.
And second is sine of the angle 90 plus omega t. Both are to give me cos omega t only.
Yes.
Which one shall I take and why? To compare phase.
I'd prefer the second one because the sine of t is the same. I mean, they're both progressing in the same direction with time.
Second one because I don't want to get omega t or phase difference in terms of time. Phase difference should not be function of time, right? If I'll take the first one, then phase difference will be function of time,
Yeah,
right?
that's precisely what I'm saying. The difference in phase would grow or shorten.
Independent of time.
Yeah.
Yeah. So what do we get from here? Which one is leading? Now in this case, you tell me which one is leading.
Is a potential difference is leading.
Potential. This potential, this current. So potential is leading current by pi by 2, in which case inductive circuit. When the circuit is inductive. So we get over here for purest circuit, if you are pure resistance, then current and voltage are to be in phase. If you are pure inductance, then current and voltage are out of phase by 90 degree, and which will lead, if inductive circuit is being taken, then voltage will lead by pi by 2. And if it's taken capacitive circuit, then what will lead? Will lead current by what angle? By angle pi by 2. Coming back to what in this case will be XC, we want to write again. Sine term taken, sine of the angle omega t minus of pi by 2 taken, everything done. What term we are left with is omega c. So what we can write? XC. Okay. What is XC to us? X is equal to 1 by omega c. What was XL? XL is omega L. Please write these down. XL is omega L. And what is XC? 1 by omega c. The terms other than current, they are called reactance. It can be inductive reactance, it can be capacitive reactance. Inductive reactance is product of omega L. Capacitive reactance is inverse of product of omega C. Where what is omega? Omega is the frequency, angular frequency. What is omega? Omega is the frequency with which rotor is made to move, or we call alternator. Alternator is made to move. Now to my question, could you please, if we have related, there must be some distinction as well. Could you please distinguish between reactance and resistance? How you differ reactance from resistance?
So I thought reactance was an umbrella term for resistance, and the two more terms we encountered into the same thing.
Umbrella term you may say when you are trying to take a cue of resistance in current. When I am to study it individually, giving it an epithet of reactance, then there is much more than what meets the eye. So what is reactance actually? If someone is being asked on reactance and resistance differential, the only way by which you differentiate is resistance will always oppose current, flow of current. Current increasing, current decreasing, whatever be the state of current, whichever mode the current will be in, resistance will oppose it. But reactance opposes change in current.
Yeah.
Resistance opposes flow of current. Reactance opposes change in flow of current. Clear? Reactance opposes what to us? Change in flow.
So I can follow that logic with an inductor, but that does not seem to be the case for a capacitor, does it?
How come not? Take omega. What will be omega for a direct current?
0.
So when you're talking of XC, which is count sense to incorporate omega there.
So
if you're not having omega, if there is no omega, then there is no point talking about reactance. A reactance will get a manifestation if and only if we have omega associated with current. And omega association with direct current doesn't stand sense, it stands logic. So reactance we are to relate with alternating current. And direct current, if we are taking, then there will be charging of capacitor. And that charging, once the capacitor is charged, it will behave steady state. It will not allow current to pass through it.
Yes, sir.
Without a change in flux, by the way, you will not get displacement current. Current flows from one plate to the other owing to change in flux only, correct?
Mm-hmm.
Without a change, you will not get flow of current, cannot get established.
So, no, but when we talk about an inductor, I mean, from what I've studied, initially the current is zero, and the potential drop across the inductor is maximum because the rate of change of current is the maximum. But eventually, when the circuit does reach a steady state, the inductor behaves like any other non-resistive wire because the current reaches a steady state and di by dt is zero.
Yes, exactly, dear. But that is a byproduct of what we learn for inductance. Inductance has got nothing to do with increasing or decreasing. When you are taking inductance with potential difference constant, then this logic will cut eyes. But what is the purpose of inductance? Purpose of inductance is to maintain current. Why will I begin with maintain phase, maintain the flux? That's the purpose. Purpose of inductance is to maintain flux. It is byproduct that you are getting whatever you are saying, that it will increase. When will it increase? When you are connecting it with a direct current. If you are connecting with a direct current source, then how will the inductor act? That we will learn. But I am into why you want to start inductance with zero current. You were into inductance and you switched it from one to the other. That may also happen. There was an inductor, current was flowing into it, and then what do? You switch from one inductor to the other inductor. Let me get your question over here. Let me hit the ground running for you and then ask. Okay. I think is visible. If not, please tell me L1, L2. Okay, I show you a question over here, right? Check. This is E. This is L1. This is L2. L2 is not connected to the circuit initially. Okay, there is R as well. Somewhere here R. Getting it?
Yes.
Now, initially, the connection was as shown. Fine, good enough, fair enough, everything good. What you then do, you suddenly switch from position 1, you are throwing switch to position 2. Right?
Yes.
Now, in this case, what will happen? What is purpose of inductance? What will the inductance try to do? You have thrown, there was current in it. You're not talking of this one. There was very much current in it. Current was flowing in it. Current was flowing in it. Current was not zero. At some arbitrary time t, what you did? You threw the switch from where to where? From 1 to 2. So when you are throwing switch from 1 to 2, then how can you stand that logic of initially current being zero, and what will happen to it? What will you do now? What will you say now is the question. So what is this inductor to do is the question. The inductor is opposition. It's not for the sake of opposing that it opposes. It is not that it is a draconian nature inductor, which is just for the contrarian view, to keep the contrarian view. What is into doing is opposing. Rather, we are not to say opposing. We will say that it wants to maintain status quo. It wants to maintain status quo. Whatever was the state of flux, it wants to maintain it. That is the purpose. That is inertia. That is inertia of inductor. So over here as well, when there was flux at any point in time when I switched it, then what was the flux through it? Flux through it was Li. It will try to maintain it. It will try to maintain it. So what will I write in this case? Li, L1I initial letters is equal to what to us? We'll learn about how do they add. So if they are in series L1 plus L2, and then what current? I prime. So I get immediately a current. In this circuit, I get immediately at t equal to 0. What is current? Someone will ask, you will say at t equal to 0, current is L1 into I divided by L1 plus L2. It is not 0. So what you're professing that initially what current, finally what current, that'll hold good when we are initiating it with that current. We are initiating it with zero current. We connected initially and it was not charged initially. With these, there was charge already. There was some energy stored already in it. When I threw switch, there was already energy stored in it. There was no energy zero state with them to hold. Correct?
Yes, sir.
Anything in? Now, to what you were saying, I'll come to this equation. If you want this problem to be solved, we'll be solving it. But before of that, charging, discharging. So charging, as you said, we are taking charging. Now tell me, I will write KVL. This is E, this is R. Current is increasing. So LdI by dt in this direction. Agreement?
Yes.
Check. Okay. I write KVL equation. What will it be? Minus of E from here to here if I go. Minus of E, VAB. Plus of IR, current this. Plus of LdI by dt is equal to 0. Do check.
Yes, sir.
Okay. Can you please get me the solution to it? By the way, I'll get you a solution. AX plus B dx by dt, direct solution, is equal to F is a differential equation. Okay.
Mm-hmm.
Then the solution for this is X is equal to F by A, 1 minus e raised to power minus A by B into t. Provided initially X was 0, at t equal to 0, X is 0. Then this is the solution. That you will get by integration, no rocket science over it.
Yes, sir.
You can integrate this keeping I as subject. Okay. You can integrate this keeping I as subject and then you will get this equation. In this form you will get basically. X is equal to F by A, 1 minus e raised to power minus A into t by B. Provided at t equal to 0, X is 0. If not, you will get another factor. If not, you will get another factor with exponential. If not, you will get another factor with exponential. Is it okay?
Yes, sir.
Okay, so over here adhering to current being 0 at t equal to 0, what do we get? I is equal to E by R. So F is how much to us? F is what to us? F is E, right? E by R, do check. Just try to draw parallel between these two equations, you'll get that.
Yes, sir. F is equal to E by R 1 minus.
By R, 1 minus e raised to power.
I think it was wait, RT by L. Yeah, RT by L.
So L by R will have same dimension as time,
Yes.
and that is what it is known as time constant. L by R is known as time constant. What do we understand by time constant? Any one of you? What is time constant?
So time taken
What
for
exactly
a
is time?
63.8% change or something like that.
That's mathematical. That is mathematical. That is mathematical. Agreed. That is very mathematics of you. Purist mathematician will say so. I know that you are a prepare for IOQM. That doesn't mean that you will be in that hubbub. So tell me, what will it be otherwise? What about physics? Tell me with physicist point of view, what is time constant? Draw for the case. I'll take help of mathematics, language mathematics only, but I will be sounding physics more in it than mathematics. This is what you will be getting, isn't it? This is the function E by R. Now, what is happening to the rate? Do check the rate. What is happening to rate? Rate is decreasing. It is getting flattened. It is getting plateaued.
Yes.
As you are moving, as you are moving with time, with advent of time, it is getting plateaued. Till it plank. Eventually it will plank, correct? Eventually it will plank. I wish to draw tangent at initial point when it begins. So this is a tangent. Wherever this tangent will cut, final value is time constant graphically. And what is time constant? Time constant is the time taken to reach final following initial state or initial rate. Time constant is the time taken to meet final value following initial rate. This is what is time constant to us. This is what is L by R to us. Got it here?
Yes, sir.
So this is what is charging of capacitor. This is what is charging of capacitor. If the capacitor was having I current already flowing into it, then if there was a current I flowing in it, and if I was in same direction as that of the current eventual, then you will simply add I e raised to power minus RT by L to your equation. Do check.
Yes.
If it was in same direction. If opposite direction, minus I e raised to the power RT by L, where I will be the initial current flowing through it.
So once
Getting
the
it?
inductor is completely charged, and if you break the circuit, what happens?
When the inductor is completely charged, you break the circuit and you connect it with the resistor, then it will behave a source.
Yeah, I know it'll discharge across the resistor, but if you just break it and just leave it be, what will it do?
There is spark. There is spark.
I
You
mean,
lose energy.
sir?
Okay, you mean to say you are disconnecting it and leaving it?
Yes.
Then current flowing through it will be zero.
So,
The moment current is zero, there will be no energy stored in it.
so it can't just
Certainly
poof into
correct.
nothingness.
Yeah, because energy will be stored in field, right? Yeah.
Yes, sir.
Energy will be stored in field. Energy is always stored in field.
Yes.
The moment you devoid it of field, where will the energy be stored?
So I thought it will still try to push current through the open circuit. Of course, it won't be able to, but it would maintain some sort of an EMF across it for like some amount of time.
That is if you're providing it a channel. For example, when you switch off a TV set, you will still see the LED glow for some time. So it is discharging because you've provided it a channel. But you're not providing any channel, then where it is to store it? It'll be stored for some time in the field that will try to generate in air. That's it. But that will not be sustainable.
Yes, sir.
Sustenance is a question over here. So this is regarding charging, and what about discharging? Can you get me discharging? If you have asked me on discharging, let us take discharging quickly. Let us take discharging quickly, right? Tell me.
Yes, sir.
Discharging of capacitor. So this capacitor was, let's say, having current I from some arrangement. Some arrangement was there because of which the current I was flowing into it. Now what do? You disconnect it from this arrangement when I current was flowing through it, and you connect it to a resistor. Okay?
Yes.
So you connected to a resistor. There was current flowing in this direction, mind you. I've shown the current flowing from where to where? From left to right. Because of the other arrangement. And then suddenly what do? You throw a switch to disconnect from the top and connect it with the bottom. Bottom is with the resistor.
So wait. So if the resistor has a resistance of 0, theoretically the current will keep flowing forever.
Yeah, correct.
That's
That is the ideal case. That is the ideal case. If we get an ideal battery, current will flow without of any potential drop forever. Right?
yeah. Okay.
Yeah. So what do we write now? As indicated, L di by dt, the mod of it, plus of IR is equal to 0. Do check there. L di by dt, the mod of it. Why am I taking help of mod? I'm not aware of which side what to do. What polarity, by the way, I would ask you, rather you, Vasudeva and Nishida, tell me what polarity would you suggest? Will the polarity with this or the polarity with this? What polarity, A or B? What polarity, option A, option B? What polarity should I remove the inductor by after of throwing switch?
So initially the current is flowing from left to right across the inductor. It would like to maintain that, so I'd assume it would be the second option.
Okay, you'd like to maintain the direction of current. That's the reason you're going with second option. Ishita, what about you?
Yes, sir. I also
Okay.
think that. I mean, like.
Okay, in that case, I take the second option. So second option will be from here to where if I move, minus of L di by dt, correct? Plus of IR is equal to 0. Correct me if I'm wrong. From here to here, minus of L di by dt, plus of IR is equal to 0. Is it okay, Vasudev?
Yes, sir.
So I write now L di by dt is equal to IR, correct? Correct.
Yes, sir.
But this will get me I increasing with time. This when integrated will get me I increasing with time, right? What will I be getting? Di by I is equal to R by L into D.
Wait. If you're going that way and you're going that way, okay, fine, all right.
Which is counterintuitive, right? Current should not increase with time. Current should not increase with time.
Just asking, is there something to do with the science here?
Yeah, of course. You asked me. You told me that current will try to. This inductor will try to get a suo moto on current, which is status quo, correct? On its own. Suo
Yes.
moto is status quo, correct? And that can be facilitated by this polarity. I've taken this polarity, fine. I write equation for that polarity, I get minus of LDI by dt plus of IR is equal to 0. Now I bring in the point which I was emphasizing then, Vasudev. Y dot. Di by dt is what to us, dear? Di by dt. If you have to take intuition or hunch into consideration, what is happening? This factor that you have taken, di by dt per se is negative.
Yes.
So di by dt per se when is negative, then that negative mathematically, how did you incorporate over here? You're not able to incorporate it, right? Because we found logic. We went with logic and we are correct on the logic. What we are correct on logic? Minus of LDI by dt, yes, it will be because this is the polarity. Plus of IR is equal to 0. Good enough. But do check over here now this equation. What is this equation facilitating? LDI by dt is equal to IR and di by dt is negative. You are equating a negative with positive. Di by dt negative.
So I think we just need to
IR
ensure that LDI by dt as a term is negative, right? Because we know that that term, which is we've written minus LDI by dt, we know that term is supposed to represent the potential across the inductor, and we know it. I mean, we know that it's negative. So, I mean, maybe we have to ensure that instead of artificially imposing a negative sign, we just have to make sure that that's negative, right?
Which is what is being ensured mathematically by taking mod, which is what it facilitates. If I'll take mod, I'm absolved of or exonerated from applying logic on what is happening to current.
So, but
Then I'm with mod plus minus both.
So, but yeah, that does work. But you've got to take a specific direction when you apply Kirchhoff's voltage law, right? So, for example, I
Yeah,
could have gone the other direction. I would have gotten IR to be negative, and LDI by dt would have been positive.
Yeah, correct. But it'll end up getting the same. You want to go which way? This way or that way? Clockwise, anti-clockwise, what?
Clock.
Go. You'll be getting the same equation. How will it be different from this equation?
So no, all I'm saying is if we go clockwise, then the potential across the inductor would drop, not rise.
Potential across the inductor we will be taking this factor, this one into consideration. If you are trying to relate it with the equation that we are getting, then this is to count. The A1 is to count. A1 will hold water, then you will be getting mathematically LDI by dt is equal to minus IR. If you will take A, you will be getting LDI by dt is equal to minus of IR.
Yes.
And mathematically it will hold. LDI by dt is minus of IR, you got it. But then when you take logical conclusion to it, di by dt is itself negative, and then this side, di by dt, LDI by dt, you got minus of IR, di by dt negative, and minus of IR also negative. So it matches.
Yes.
Di by dt minus IR if I get, then it's a match because di by dt is negative and minus of IR is also negative.
Yeah.
The polarity is, we will be going with A. If I'm to give it polarity, then I'll be going with A. I'll not be going with B. If I'm to take polarity into consideration.
So
If I go with A,
I think you've displaced your microphone. Your voice is muffled. No, it's not.
LDI by dt is what I was not fine. As of now, also not fine. Not good.
It's certainly not as good as it was before.
Okay. So that's the capacity, I presume.
Okay, it's
Because
fine now. It's fine now.
Okay, 47 is what minute been, and it's showing 15%. Maybe as getting discharge, my voice will get more and more muffled and garbled. Okay, so let's check. Let's check. Okay, this is what the situation is there, and then we are freezing it with this one, and freezing it with this one should come with logic then. How did the current get an opposition in inductor? What was happening? How did the inductor initially in this case at least, how did the initial inductor act? This initial function of inductor, what was it? It was to oppose current. It was to oppose current, right? If you had to take the physicality of the situation, it was opposing current.
Yes.
And that we can understand by very thought process. If I'm to take a thought process over here, that it was being charged initially. Now what happened? The current started in a way. If you're connecting to it, throwing from this position to this position, then current started increasing in it. Can you take that base? Can you apply that logic? Is what I'm asking. Think about it. I'm keeping it open-ended. But I want to come with a mathematical conclusion. So if I'm going with a mathematical conclusion, I'll have to take this into consideration. I have to take A into consideration. If I take A into consideration, then how can I, with the logic, physics backing me, suffice an evidence to it? Or is it that I'm to go just mathematical the way that we went in pressure? P is equal to P naught plus rho GH, if you remember, and the other case we were getting P is equal to P naught minus rho GH. Why? Because we were going wrong in the differential form, x dx form. We were applying logic that weight will be high, so dW, and accordingly we landed ourselves in soup. If you can recollect, Vasudev, have I taken fluid with you?
No, you haven't taken fluid.
Okay. So there was a logic, and when we went with logic, then we did fix ourselves. So sometimes mathematically, if we are moving, then dW, when you take dW, it can be positive, negative, as we know, and accordingly, not all. If I take logic and take dW as positive, then I'll show you in pressure case what do we get, what do we end up getting is P is equal to P naught minus rho GH. You will not get P is equal to P naught plus rho GH. Okay. So if you are, why I'm bringing that point for, I want to make a conclusion, a conclusive statement to what we have kept open over here. Are we to go purist mathematics and see for di by dt, or are we to assume that an inductor is to act this way initially? That means it opposes flow of current.
I have a fundamental problem with the first option, because if you were to apply KVL clockwise, right, and if we were to start at the top left point, then across the inductor potential would drop.
Yeah, it will be minus or plus minus. So VA minus VB, VA minus V will be positive or negative?
Negative.
Why will it drop?
So VA minus VB will be positive because of the polarity of the battery. The VA must be higher than VB.
How do you know this is high? That is the entire of the question is based on which end will be high, which end low. How is known to you?
So I'm saying if we assume the first one's right and we go clockwise, we know the current has to be at least initially clockwise, right? Because that was how it was set up by the battery.
Correct.
So the potential must drop across the resistor. It's also dropping across the battery, and that's not possible. I mean, that loss potential has to be made up, or Kirchhoff's voltage law is violated.
That was current. In this case, also current was clockwise there, but it behaved this way, right? Because it depends on what is happening. It is not on the flow of current; it's on the rate of change of flow, right?
Mm-hmm.
So rate of change of flow it depends on. I'm not deciding on flow of current. Resistance is different from inductor.
Yes, sir. So all I'm saying is the potential across the resistance is independent of how the current is changing. So that'll always drop. But if it also drops in the same direction across the inductor, then that loss potential cannot be made up. So if you go around in a loop, sigma V won't be zero, right?
Correct.
So I'm saying option A isn't a potential choice.
And can you base your logic on flux maintenance?
Flux maintenance, how? I don't get the complete context of the question.
Here, if I bring back to this question,
yes,
the flux initial before a throw-off switch was L into I.
Yes.
When you throw a switch, let's say they add as resistance, so L1 plus L2. For initial current, I prime. Current will change.
So wouldn't there be a transition period between I and I prime?
I and I prime. Yeah, immediate. The moment you throw the switch. Yeah. In fact, this is the question. Find current in this circuit as function of time. Take it. Find current in this circuit.
Wait. Immediate. That's a bit counterintuitive. I mean, I always imagine inductors as being these slow-acting components which always take a while to reach the steady states.
but you didn't get it any while to resurrect. Yeah, you have thrown the switch. It can show the vent in form of sparking if it's that allowed.
Yes, yes,
If it's that allowed, it may spark. You didn't get any time to it, right? The current was flowing, it was set. And then you threw it from one position to the other position. What will be current then? How will you relate the previous with current flowing now?
So okay, I have another question here. You're saying the initial current, I mean, before you flip the switch, it had achieved a steady state, right? A phi 1. So I
Yeah, it
whatever.
is.
So
Yeah.
then when you flip the switch suddenly, my question is, current was already steady, it wasn't changing. So current through this new inductor will also from the moment it starts, it'll be steady, it won't be changing. So essentially, this new inductor should act like a free non-resistive wire. Why is it even impacting the circuit in any measurable manner?
When I have flipped it, okay?
Yes.
At that time, if I was asked, tell me what will be current, and I want a function of time. Let's say it's not steady state. Okay, then what would have been the current given to me? Equation wise, E by R, right? Into 1 minus e raised to the power minus RT by L1. This would have been the current. So this current was flowing in it at T equal to T. And that is the time when I decided to switch from position 1 to position 2. It is not steady state.
Yes, sir.
Instead it being steady state. I'm not taking steady state, I'm taking an arbitrary state.
Okay.
This is the current flowing through it. I want to switch it now.
Alright.
I want to switch it now, then I know that okay, L1, L2 and R, I can still write the equation. What that will be, that I prime, let us say, is equal to how much? Is equal to E by R and 1 minus e raised to power RT L1 plus L2. If we are aware of, that will be L1 plus L2. But then this equation is getting me at T equal to 0, current being 0, which is not the case. So I prime when I take, what was current at T equal to 0 should be known to me. T equal to 0 over here, I refer to the time when I am switching it. At that time, current was how much? Current was this much, right?
Yes.
So this factor will feature in this equation, correct?
It should.
Then I'll have to relate I with I prime.
Yes, sir.
And I with I prime can be related by going back to the component. Which component? Inductive component. What is nature of circuit? What is nature of inductor? Nature of inductor is to balance or maintain flux. That's it. Phi is equal to Li. That is what we do. So now my battery is showing 5%. I think we are up with the class. We'll be checking on this. If there is any doubt left on this one, if you can get me the equation for the current eventual, which is I prime, will help by maintaining flux. This is the flux maintenance. This is the relation between I and I prime. I prime is the initial, that means after of the switching, after off switch, and I is before off switch.
Sure. Can you just tell me where you got this flux maintenance thing from? Because I've never seen that before. I mean, I've never read the law of conservation of flux.
Inductor means maintenance of flux. Phi is equal to Li is what we got to begin the class, dear. Phi is equal to Li.
Yes, phi is equal to Li, but I haven't come across anything that's saying phi change is 0. I mean, that's
Phi,
essentially what you're
what does
professing
it-
here.
Well, exactly. Why do we get EMF induced when flux changes, right?
Yes.
Yeah. So flux change will induce an EMF, right?
Yes.
An inductor which I have taken with certain flux linking through it, phi is equal to Li, and is an equation which I am getting. So there is a flux linking through inductor. What will it try to do to energy? Will it try, if I am switching, if I am taking, let's say taking a capacitor or inductor, whichever you take. When you want to change field through it, will not there be an opposition? Will the inertia not work over here? What was it doing? Remember, what was the magnet being done? If you're bringing magnet close to a loop, what was that loop doing? The loop was approaching magnet, correct?
Yes.
Why? Because it wanted to maintain inertia, status quo. And when it was leaving at that time also, it was trying to oppose it.
Yes.
So in both the cases, it is trying to oppose the motion, oppose change is what I'm getting. Coming near, opposition, going away, opposition. It is trying to oppose change.
Yes.
And the more something is trying to oppose change means it is trying to maintain or keep it constant, right? Oppose change means trying to keep it constant, correct?
Yes.
That is what we are coming, right?
Okay.
Okay, dear.